Good morning and welcome to AXA Arctic Live. It's fantastic to have you all with us for this live investigation today. And we're looking at sampling techniques and how to sample for plastic in the Arctic. My name is Jamie from Encounter EDU, and it's fantastic to be joined by Chloe, who's joining us from Exeter, Chloe?
Yes, from Exeter University. Hi.
Hi, Chloe. Very good morning to you. Chloe, part of the Arctic Live science team, and together what we will be doing, answering some of your questions about plastics in the Arctic, and also looking at sampling techniques. So this is very much a working scientifically first half of this live lesson. How do we know what's going on? For those of you who are tuned in to yesterday's live lesson, we looked at different types of research, all from satellites to walking across the Arctic to being based at a research station like we would be in Ny-Ålesund. So very much we are on virtual Arctic Live, but if we were in the Arctic, we would be based at the UK's Arctic Research Station, and that's operated by the British Antarctic Survey, and that is in a science community called Ny-Ålesund on an island called Svalbard. And I've got a map, or I've got a globe here. I'm going to turn it around to show you where that is. So let's grab a pencil here. Oh, we've got my virtual Arctic misbehaving this morning. So where are we? Here we are, Svalbard here. And then you can see Europe, Greenland, Iceland, and the UK there. So we are halfway between Norway and the North Pole. It's the most northerly permanent community in the world. And Ny-Ålesund used to be a science settlement. It used to be a coal mining settlement, and then turned into being a base for science about 50 years ago, over the past 50 years. And countries from the UK, Norway, Germany, France, the Netherlands, China, a host of different countries have research stations up here. And while we're up in the Arctic Live science is twofold. First of all, looking at ocean acidification. And we had a few live investigations on that on Monday, and then coming back again to look at that with Dr. Helen Finlay from the Plymouth Marine Laboratory on Friday. And the second piece is plastics, and that's the focus of today's lesson. And also we have Dr. Kerry Lewis from Exeter University coming in tomorrow to answer all your plastics questions from the Arctic and beyond. So it's fantastic to hear from her then. But we have a great live lesson for you. We're going to do the live investigation with you, and then we're going to come to questions that have been submitted in advance, and then questions from the live chat. The live chat is found to the side of the video, and please do remember that if you're using the live chat, it is using YouTube, which is a social media platform. So if you're under 13, you should be logging in with a parent, guardian, or teacher and posting comments there. Please do remember it's a live classroom. So that means you need to be keeping your topics and your shout outs and your questions on the subject of the Arctic sampling techniques and plastics. So thank you so much for doing that. We'll get started in just a minute, but I've been sent through some fantastic shout outs. This is a big shout out to all the very hardworking and dedicated Year 8 students at Green Hill School in Tenby. Well done for all your maturity and hard work. So fantastic to all the Green Hill School students who are watching. Thank you. We've got Thomas, who is homeschooling and is a budding marine biologist. So very good morning to Thomas. Ernie has watched live or caught up later every lesson since the lockdown has started, and they have all been really great. and really interested in learning more about our world through science. So thank you, Ernie, for being one of our new generation of scientists, and it's great to have you on board. Hi to everybody from Oakfield Academy. Hello to all the students watching from there, to Greenfields High School Higher Environmental class, and that's from Morrow saying hello to all the students watching from there, and a big hi from us too. Good morning from everyone at Good Maze Primary School. Hi to all the Good Maze Primary School students. Class 2 at Lamington Primary. Oscar, wouldn't be a live lesson without Oscar. And hello, Alex, I've got from Cransley School. So good morning to Alex from Cransley and all the other students watching from there. Great to have you all on board. And we've got quite a spread of ages. So we're going to look at sampling techniques probably in a couple of ways, and you can replicate this at home. So the first thing Chloe and I are going to talk about is sampling. Now, if you have looked at the preparation for this lesson, what we normally do is look at sampling for plastics in ice. And the way to do this is to get a plastic tray and to sprinkle in it some colourful lentils or pulses or something. I've got split peas today, but anything will do. Fill it up with ice. If you want to make it a bit easier, make the ice salty. That's easier to sample through. I haven't done that today, just so it's nice and solid. So that replicates sea ice, which is easier to core, and that is about 35 grams of salt per litre. Now, if I show you my ice, because we're going to go through this together, can you then see that all my split peas have concentrated at one end? We know this is normally the case, and if we were to have the ocean coming onto the ice front, we can see normally a higher concentration of plastic particles in the ice being brought by the ocean currents, by the waves, and then freezing onto the front of the sea ice. That is what we find. But we only know that because we have taken samples all the way through the ice. I've got a potato peeler here, and just think how we would have found that out. So I'm going to take an ice sample. I'm going to take one ice sample because if I know anything from having worked on Arctic expeditions, ice, sharp objects, and computers do not go well together. So be super, super careful with this and work with... No, it is getting really... I'm going to destroy my computer. I'm going to tip out the bits of ice. So what you'd want to be doing here is with an apple corer, looking at taking samples of different types of ice. I normally put snow on top so I can't see where it is. Chloe, is this a common problem in science where if you don't know where anything is and you want to know how much there is? Oh, I'm about to drop this is probably an easy way to talk about it here. So I can see very clearly in my ice here where the plastic particles are, but if there's snow on top, how would I go about thinking about how to estimate the number of plastic particles in this piece of ice?
Yeah, so it can be really difficult sometimes when you go out into the environment and you're looking for something specific like microplastics and you don't actually know where they're going to be. So it's sometimes important to do a random sampling method, and this means randomly selecting locations in your survey area to collect samples. And this way you can try and make sure you have a representative sample.
Brilliant. And what we try and do in the Arctic on Arctic Live is can you see behind me, for those watching, sort of mountains in the distance? There's also mountains in front of me. We're on a fjord. So that's in a sea inlet, so like a narrow body of water with a glacier at the head. And so we don't just sample in one place. We don't drive out into the middle of the fjord and just drag our nets through the water. And we'll come on to that in a bit. But we try and do a representative sample along the fjord. For those of you who are sort of younger students watching, I'm just going to ask Chloe now. This is really about estimating, isn't it? When we take samples, estimating what's going on in the environment. What would you say are the benefits of doing an estimate through samples versus sort of sampling everything?
So sampling everything would be really, really challenging, especially in the ocean. The oceans are so huge, so trying to sample everything would be virtually impossible. So we kind of have to meet in the middle and estimate by taking a range of samples that are smaller, I suppose. So estimating really is coming with a balance between wanting to see everything and trying to just see as much as we can to get an understanding of what's going on.
Brilliant. So for younger students, I'm just going to pose you a problem. This is a polar bear mug. It has lots of sweets in it. Okay, I would like you to estimate what percent are blue sweets. Okay, how many blue sweets are in this mug? What percent do you think it's? Maybe 10%, 20%? And I'm going to take one sweet out. How many blue sweets do you think are in here? How many blue sweets do you think are in here? And I can keep on going like this. And if our sample was only bringing up orange, brown, yellow, and we're thinking, okay, well, there are in fact no blue sweets in here, it is very, very difficult. Now, if I tip my cup up, you can see, in fact, there are a number of blue sweets in my cup. So the difficulty as scientists that we have is how much can you, as Chloe was saying, how much work can you do? It's very difficult to sample the whole ocean before we get a really good understanding of how many different coloured sweets there are, or how many of each of different colour of the sweets there are in the ocean. I think that probably Chloe and I would agree that doing more and more and more sampling is probably a really good way of finding out how our environment is working better. And there are also new techniques using machine learning, which we'll come on to a bit later, as well as other technologies. Now, if I can swivel round, and Ellie, the producer, will tell me whether that's okay in terms of showing what's behind me. When we're in the Arctic, we're on a small boat, and the way that we sample for plastics is by dragging a net on a winch behind the boat. And we're looking at where those plastics are, and they collect much like a sort of shrimping net you might have had for rock pooling beside the sea, but with a very fine mesh so that we collect these very small plastic particles in the Arctic Ocean. So this live investigation part, slightly hampered by having ice and sharp things too close to a computer, but just to demonstrate some of the challenges of doing science. If you wanted to know what's going on here, the decisions we make are to take representative samples along the fjord. We use a net that is fine enough to collect those samples that we're looking for, so that if we use a net with holes this big, then all the plastic particles that we're trying to sample for would escape through it. We're also taking more than one sample from each place. that means that we have replicates. So if something goes a bit wrong, we know that we have another sample to test it against. And the other thing that we're doing is doing this over multiple years. That helps us to understand change as we go on. We go back to the same places each year. So in our little logbooks, we have the GPS coordinates where we sampled over the past 2 years. And when we're back up in Nielsen, hopefully next year, we'll be able to go to those exact places and get an understanding of the changes that are occurring. Now it's time to move to your amazing questions that have been submitted in advance, and thank you very much for sending those through. You can also add them to the live chat as we go on. So Chloe, we've got an amazing range of questions here. I'm going to go for a couple of topical ones first, and these are from Cransley School. There's a worry here that the increase in plastic waste from items such as PPE, personal protective equipment, being used by frontline sort of care and medical workers, that they're wondering whether that will affect our sampling, so the amount of plastic that we find in the coming months and years.
So yeah, that's a really good question, because there is a lot of plastic that's used in healthcare. So we would firstly hope that these items are being disposed of properly. So they're being put into waste bins and yes, being disposed of in an appropriate way. In some cases where this might not be happening, then as with other plastics, we might find that they're finding their ways into waterways, into rivers, and then into the ocean. But we'd be hopeful that they're being disposed of properly. And so
I think with most sort of medical organizations will have really rigorous waste management processes. I think there have been some documented examples of maybe people using those outside of those organizations where it's seen as an increased litter. So please, if you are using personal protective equipment, whether that be a temporary face mask, is to ensure you dispose of those properly, or plastic gloves. But if we take a step back, Chloe, and there's this really great question from Goodmayes Primary School. We're talking just generally about sort of plastic waste, as if everybody knows that it's in the ocean and that it's a problem in the ocean. Sort of why and how do plastics land up in the ocean?
That is a very good question. So, as we know, plastics can end up in the terrestrial environment. So, in our parklands, on our roads, because they're not being disposed of properly. So, litter is ending up in the environment. And then what can happen is these plastics can end up in our rivers, in our waterways. So they can be washed into the rivers or the waterways from the rain, or they can be deposited there. They can actually be kind of thrown away near a riverside and then get washed in. And this is where we need to remember that all of our rivers actually run into the ocean. So this is how the plastics end up in our ocean.
So, I mean, I think we've got, it was about 80% of plastic waste in the ocean coming from land, coming from sort of poor disposal from other places, and then about 20% from sort of lost sort of fishing gear, from stuff coming over the side of boats, or from nurdles. I've heard of this nurdle term being washed over boats. Chloe, what's the nurdle all about?
So a nurdle is kind of a virgin plastic. It's a very, very small piece of plastic, and these are used to create other plastic items. So they'll be going to the factories to be manufactured into plastic bottles or other pieces of plastic equipment. And sometimes when these nurdles are in transport, they can end up in an accident, I suppose, and be tipped overboard or be tipped out on the road, and then they can accidentally get washed into the ocean.
Brilliant, thank you. And Chloe, we now know that there's a huge amount of plastic getting into our oceans each year. From memory, I think it's something like 8 million tons a year. Is that I think I've got the right figure there. But from Greenhall School is wondering sort of, so how do those plastics affect wildlife? Why should we worry about plastic being in the environment if it's certainly something that we use a lot in the home environment? Why should we worry about it being in the ocean?
So this is a really good question, and it's actually something that we as scientists don't know a huge amount about yet. There's a lot of research going on at the moment trying to help us understand and learn what the problems are with plastic in our oceans and in our environment. But some of the big things that we've seen already, and you'll probably have seen photos of these on social media or even on the news, is large pieces of plastic, for example, fishing nets, can actually get caught up in some of the animals' bodies. So you might have seen fishing nets around seals' necks, or you might have seen straws stuck on turtles. So some of these big pieces of plastic can actually quite negatively harm some of our organisms in the ocean. And also what we're starting to see is that some smaller organisms are actually eating microplastics. So they're going inside of their stomachs. So we don't know too much about what kind of effect this is having right now, but there's a lot of research going into trying to find this out.
Thank you. So we've got this entanglement piece, and I've heard that sort of lost fishing gear or discarded fishing gear is a big problem for this, for everything from sort of sharks to turtles to seals. We've got these problem of different species eating bits of plastic and confusing it from food. Everything from sort of we've in the news we've had examples of whales. It's very well documented with turtles confusing plastic bags for jellyfish, and then also seabirds as well, especially the albatross. Some devastating photographs by an amazing photographer, Chris Jordan, from Midway Island. But what you're saying then is that tiny bits of plastic can then get into tiny creatures. Had those big bits of plastic, so if I were a horrible person and just tossed a plastic bottle willy-nilly into the ocean, how does that turn into something that's small enough for a tiny creature to eat?
That's a good question. So a lot of the plastics that end up in the environment start to break down slowly over time. And as you know, it takes a very long time for plastics to degrade completely. But what you'll find is chemical and physical weathering causes very small parts of plastic to come away from those bottles. And that's what you call microplastics. So tiny bits of plastic that have come off from larger pieces. And this comes through physical weathering, so being knocked about against other things, or chemical weathering. So this is some chemicals in the ocean water which start to break down and degrade the plastic.
Brilliant. And we're coming on to a slightly sort of question that sort of to the side of all this. So we've got these tiny particles getting into the plastics. But the question coming in again from Greenhill School is do scientists, when they're doing the research, do they add to the plastic waste problem? Is that something on previous projects that you have worked on? Has that been a problem? And then I'll talk a little bit about what we do in the Arctic.
That's a very good question, because as you know, plastics are used a lot in everyday life and also in science. They are really, really useful, really helpful in helping us to do our scientific work. So that's a really good question. And when it comes to microplastic research, we have to have a lot of protocols in place to reduce contamination, because some of the equipment we use is made out of plastic. And you also will probably know that some of the clothes that we wear are also made out of plastics. And fibers can come off of our clothes and go into our samples. So it's really, really important that when we're sampling, we try to wear cotton-based clothes so that we're not then potentially at risk of putting plastics from our clothing into our samples.
And it's something in the Arctic we're very concerned about, both from an environmental impact and from the accuracy of the science. So we'll sadly, we don't wear tweed jackets and that kind of thing. We do wear synthetic fibers to keep safe in the Arctic, but we do try and use fibers that are made from recycled plastic, such as the jacket I'm wearing at the moment. And then good old woolly jumpers underneath that. But living at the community in Ny-Ålesund, it's the recycling there is absolutely amazing. I think there's 21 different categories of recycling, and the awareness you have of your environmental impact is huge. So there's some really great environmental policies in place. And then there is a sort of the annual Ny-Ålesund beach clean in the summer. I mean, certainly some of the waste that I've seen around has been what we've talked about, that sort of shipping waste, sort of old bits of rope and bits of buoys that have washed up on the beach. That's the obvious example of plastic pollution up here. So look at this. These are really, really tough questions, and I don't think that our watching audience realize how difficult some of these science questions are to answer. The question coming here from Greenhill School asking, what plastics do you find most?
That is a really tough question. And it really depends where you're looking, actually, where you're collecting your samples. But in general, a lot of the samples are coming up with fibers, so plastic fibers, which typically come from clothes. And this is what we've seen, a lot of.
So, Chloe, I think we lost you there shortly for a little bit, but you were just mentioning there that the small fibers are what we're really finding in the ocean, and those coming from synthetic clothing like polyester. And there's some, and I forget the number, some huge number of microplastic particles generated by an ordinary sort of laundry wash in a home washing machine, and much of that going through the sort of sewage system, wastewater system out into the environment. Is that the case?
Yeah, it's actually a huge number. It's very scary because you don't realize that in your everyday activities, wearing and washing your clothes, you're actually contributing to some of the pollution in the oceans.
Brilliant. Well, thank you for that. And what I'm just going to ask now is to look at describing the worst example of plastic waste that you have seen.
Oh, that's a really difficult one. That's a very hard question. Worst example of plastic waste. Well, single-use plastics have to be the top of the list there. So these are the plastics that we use one time and then they get thrown away. I find that quite difficult to comprehend, the idea of using something one time and throwing it away. And sometimes they're not thrown away properly, and that's how we end up with big pollution incidents.
Brilliant. And I mean, this idea of single-use plastic was we've probably heard quite a lot about. And what are some of the things, very simply, that people can do at home now, during the pandemic, to reduce their single-use plastic?
There are so many ways. It's amazing, actually, how much good work you can do now to try and reduce single-use plastics in your life. So using maybe a cotton bag or a reusable bag when you go shopping instead of plastic bags, that's a really important one. And now there's so many steel water bottles available for use as well. So we don't need to be using bottled water. We don't need to be using plastic bottles. We can refill our own bottles from our homes and take them out with us. There's so many really great ways.
Brilliant. Thank you, Chloe. I mean, I think there's this big debate here, and there's a couple of questions coming up here. And this is from Green Hill School again. And we've talked about these small plastic particles, microplastics, less than 5 millimeters across. A lot of that coming, it seems, from fibers. Those fibers are being found a lot. How can we clear all this up? Why aren't we focusing on clearing up this problem using nets instead of studying how it behaves?
So this is a really good topic actually for discussion. And I think it's important to remember here that what we need to try and think of is reducing the amount of plastic that we produce. So turning off the tap, as you say. So we want to try and stop putting plastic into the environment. This needs to be our main goal. If we can clean up plastic pollution that's already out there, that's amazing. But really, we need to be thinking about how we can stop producing it and stop polluting in the first place. And when it comes to microplastics, they're very, very, very difficult to clean up in the environment. And the ocean, it's so big, so big. Trying to reclaim all of that pollution is going to be really difficult. So we need to start thinking about how we can actually stop plastic pollution going into the ocean from now.
Chloe used a term there, turning off the tap, and I think the other side of that is bailing out the bath. Could you explain those two terms and how they relate to plastic pollutions, so those watching can get a grasp of those concepts?
Yeah, of course. So when you realize that something isn't working, that something is a problem, it can be easy to react and say, okay, well, we need to try and solve this problem. We need to get rid of all the plastic that's already in the environment. And that is great. It really is. However, if we continue to produce plastic, then as we take plastic out of the ocean, more is going to keep going in. So that's when we get these two terms, turning off the tap and bailing out the bath. So if we're bailing out the bath, we're taking out all of the water, but the tap is still on, then the water is just going to keep on filling up. And this is really applicable to plastics. If we turn the tap off, however, and we start bailing out, you'll start to see that plastics, or the water in the bath, goes down and stays down.
Brilliant. Chloe, thank you so much. I'm just going to turn to the live chat, and so some really great comments and questions coming through. There's some human health impact questions. So obviously a lot of people around the world eat seafood. So if the animals in the sea are potentially eating plastic, does that mean we are eating plastic? And if so, is there a human health problem with that?
Yes, there actually is. There has been some research that has shown that there are plastics in some of the seafood that we eat. And there's a term for this in science called bioaccumulation. So what's happening is the small plankton in the ocean are eating small plastics. Then the fish that eat the plankton are also taking up the plastics that are inside these plankton. And it goes up and up the food chain to the point where we're eating fish and seafood, which has plastic inside of it.
And should that concern us? I mean, from understandings that I've looked at, different types of seafood will have different levels of plastic in them. So if you're eating a fillet of seafood, it might have less plastic in terms of, the muscle. If you're eating something where you're eating the whole body, so the guts as well, such as mussels, I think there's a study from Belgium looking at mussel eating or whitebait or this whole food. Is that the case?
Yes, that's definitely the case, because as we are saying, the microplastics are being eaten by these organisms. So they tend to be in their guts, in their stomachs, in their digestive system. So if you eat the whole organism, that's where you're most likely to also be eating plastics. And this, we're expecting, can have health impacts, but there's still a lot of research that needs to be done.
Okay, so it may have health impacts, but you do have to eat a lot of mussels, I think, to get the same amount of plastics in your body from them, as opposed to the natural environment. So there's plastic in the air for most of us at the moment. There's plastic coming from the packaging your food comes from. And now, as the science community or the medical community working out whether those small plastic particles have an impact on human health. Is that where we're heading in terms of research?
Yes, definitely. And as you say, these plastic particles, these microplastics, are so small. So you would have to eat a lot of mussels to consume a large amount of plastic. So it's important to remember that. But yes, there is research going into looking at whether this is going to have health impacts for humans and for animals.
Thank you. Lots of questions coming up on here. Just on some basics on plastics. And obviously, people are quite impassioned about working to reduce their plastic consumption. Is that we've got one question coming through from username Tamsin Clements? Is that we've talked a little bit about animals eating plastics in the ocean. Why do they do that? Why are they eating plastic rather than their normal food?
That's a really good question. And there's a couple of reasons, actually. Firstly, is some of these plastics, they look very similar to the foods that these organisms usually eat. So sometimes they can't tell the difference. They're looking for something the same size, or maybe the same shape, or maybe even the same color. So they can't differentiate between the plastic and their food source. Sometimes also in the ocean, the plastics can accumulate possibly plankton or other organisms, and this can make the plastic smell exactly as the organism's food. So it's really difficult sometimes for them to not get confused between plastics and their food.
Chloe, thank you very much. We just had that question repeated by username Ruby Ahern. So I hope, Ruby, that helps you to understand why animals in the ocean are eating plastic. So basic question here from username Fedor's Hasham is, how many types of plastic are there? When we talk about plastic, is it just one type of material, or is it more than one?
There's actually many more than one, many more. So there's many different chemical formulas of plastics, and there's many different types. So you'll see the thin types, the thicker types, the fragments, the fibers. So this is what makes it such a complex issue, actually. There's so many different types of plastic.
Brilliant. And I think for those of you in the UK and certainly internationally, you'll probably see numbers inside sort of arrows on some of your plastics. Those refer to what are called resin identification codes that show you the sort of 7 main types of plastic, although number 7 is other. And just to remember that the plastics coming from oil, coming from fossil fuels, these synthetic plastics, but then we'll have many different additives from flame retardants, colorants, different chemicals to make them flexible and to give them the properties that we use on a daily basis. So some of the plastic products that you'll be using will only be half sort of oil, the main part of the plastic component, and then the other half can be a whole host of different chemicals to give the plastic the properties for the use it's being designed for. So really a very large amount of plastics out there. We're coming towards the sort of the end of this live lesson, and Ellie, who's our live producer as well as eco-entrepreneur, science communicator, and perhaps many other things as well. Ellie is working on bringing new techniques to sampling for plastic. So while we're here in the Arctic using a standard net to trawl behind a boat in certain places, so a set sampling sites, Ellie's got something quite exciting up her sleeve, which she's been trialing at the over the past year or so. Ellie, are you there? And can you share an exciting way of using technology as part of finding out more about the plastic problem?
Hello, yes, I definitely can. I'd love to share it with you. Plastics for me have been a big part of my life for the last few years, because as Chloe and Kerry and all of the scientists we've been speaking to this week have all seen, it's a real problem in our oceans. And I was particularly interested in how we could use new technology to try and map and count some of that missing plastic that goes into our oceans, and then we don't know where it's gone. So we've been hearing today all about how you can sample for plastics and the difficulties with how to choose where to sample, how often to sample, how many samples to take, and how to make sure, or how to know that your samples are what we call representative of reality. You know, if you just take one little sample area, how do you know it's the same situation elsewhere? So what I've developed is a technique using two new types of technology to rapidly assess a large area, so that we can compare that to the samples on the ground to see kind of how accurate those samples are, or how representative they are of the big picture. So what I do, and I'm just going to show you a couple of photos here, is run a company called Ellipsis Earth, which is an environmental monitoring company. And the first technology we can fly those drones over the beach or over the ocean surface quite rapidly and cover several kilometers of land. And we could also do that in places that we couldn't get people on the ground. So maybe you couldn't sample, you couldn't access, so remote areas. And then we get a photograph like this. And those sorts of photos, you can see little boxes, because the second type of technology that we use is called machine learning. So this is where we've taught a piece of software, an algorithm, which is a piece of computer software that learns, like a human, to look for plastics and identify those plastics automatically. And so what happens is our our images can be scanned, and then the algorithm can detect all of those pieces of plastic. So this image you see here, every single one of these boxes is a piece of plastic that's been identified by our system. And then finally, we can pop that onto a map like so, and just show a heat map or hotspots, so that we can actually map where these plastics are accumulating. So if you're interested in finding out more about that, you could go to our website, which is www.ellipsis.earth, and you can find out all about this kind of big scanning, surveying system that we've got.
Brilliant, brilliant. Ellie, thank you very, very much for sharing that. And just for students who are watching, you're interested in drones, you're interested in computing, algorithms, machine learning, all those technologies can be applied to environmental issues. So learning about how the environment is changing can stretch all the way from tried and tested robust techniques up in the Arctic. When we're doing Arctic field work, we normally like things that are very happy at minus lots. A lot of the things you might use elsewhere and are happy in those temperatures tend to break in the Arctic. We break quite a lot of equipment, science equipment in the Arctic, because it really doesn't like the cold so much. We sort of rip nets and that kind of thing. So a lot of the equipment that we use is super, super robust. But just before we end this live lesson, I've just seen a comment here on the live chat about the amount of waste that is recycled. And I think a recent research came out that only, I think something between 7 and 9% of all the plastics that have been produced have been recycled. And that's been a sort of decade-long study. Those rates are getting much better. But do remember that recycling is just one of the 6 R's. So if you're looking at, solving or tackling your own plastic issue and the plastic issue in your community, recycling is great, but really think about reusing plastic, refusing single-use plastic, especially redesigning, just rethinking how you live your life, really moving away from those wasteful plastic products, those single-use products. And that first question that we came to about PPE, plastic can play an incredibly important role in medical hygiene. So it does play a really important role in various sectors of our society. But do take this time to reflect on whether the plastic you use, or maybe you've stopped using because you're using less convenience, food and drink, how you can sustain those habits into a post-lockdown world and lessen the impact on our planet. Chloe, thank you so much for joining in and sharing your experience in terms of sampling and your knowledge of plastics. Ellie, thank you so much for sharing an insight into how we can tech up our understanding of the natural world. And thank you to everybody who's been watching and the great questions that you've been sending through. Do remember that we have more sessions on plastics where we're moving away from talking about sampling and more about the plastics issue in general and how it's affecting marine life tomorrow with Dr. Kerry Lewis, both in the morning, I think it's 11:30 UK time, and then at 5 p.m. in the afternoon, that's UK time again. And what we'll make sure, if you're still a little bit confused about what exactly plastics are, we will do a little bit of a primer at the beginning of each of those sessions, just so you've got that knowledge up front. But thank you again. And for now, from Arctic Live, it's bye-bye. Bye-bye.